Crash Course Instrumentation, Episode 3, Instrumentation Fundamentals Series, Wastewater Disinfection Control. Welcome back to Crash Course Instrumentation. Today, we're exploring a real-world system that's vital to both public health and environmental safety, a wastewater disinfection control system. Wastewater treatment plants clean up used water before it's released back into rivers, lakes, or the ocean. But before that water leaves the plant, it needs to be disinfected, usually with chlorine or ultraviolet UV light. Today, we'll focus primarily on chlorine-based systems, but we'll also touch on how UV disinfection works. Why disinfect? Because untreated wastewater contains harmful bacteria, viruses, and parasites. Disinfection is the final barrier that prevents disease from spreading into the environment or drinking water sources. So how does instrumentation help? Let's break down a basic chlorine disinfection loop used at many treatment plants. 1. Flow transmitter. Measures the flow rate of treated wastewater moving toward the discharge point. This is typically a magnetic or ultrasonic flow meter. It sends a signal, often 4 to 20 milliamperes, representing the current flow in gallons per minute, GPM. A controller uses a flow-paced control strategy. That means instead of using a static set point, the controller calculates the proper chlorine feed rate based on how fast the water is flowing. More water? More chlorine. Less water? Less chlorine. This is proportional control, one of the simplest and most effective strategies. 3. Chemical metering pump. This is the final control element. It injects a chlorine solution into the water based on the controller's output. These pumps are often variable speed and calibrated to deliver accurate dosages. Typical dose ranges vary depending on the facility and water conditions, but common targets are around 1 to 5 mg/L of chlorine. In more advanced systems, a residual chlorine analyzer is installed downstream to measure how much chlorine remains in the water after disinfection. This creates a feedback loop similar to a PID system, but in many smaller or older plants, the system is still open loop or uses basic proportional logic. Now let's talk about local versus remote, DCS control. In some facilities, the flow meter and pump controller are located together in the same cabinet or room. This is a local loop, meaning the control happens nearby with minimal latency. In contrast, modern plants often use a distributed control system, DCS. In a DCS, the sensor signal is sent to a remote operations center where logic and trending are handled digitally. The command is then sent back out to the pump. While this adds complexity, it also improves visibility, record-keeping, and alarm management across the entire facility. And how about UV disinfection? UV systems use high-energy ultraviolet light to neutralize microorganisms. Water passes through a chamber with UV lamps. As pathogens are exposed to the UV light, their DNA is damaged, rendering them unable to reproduce. Unlike chlorine, UV disinfection leaves no chemical residue. However, it has limitations. It only works on clear water. Turbid water reduces effectiveness, and it provides no residual protection in the piping that follows. Here's a fun historical connection. The use of chlorine in water treatment began in 1908 in Jersey City, New Jersey. It was one of the first cities in the world to add chlorine to its drinking water supply, drastically reducing outbreaks of typhoid and other waterborne illnesses. That success paved the way for using chlorine in wastewater treatment decades later. From a physics perspective, this process also highlights the concept of dose equals concentration x flow rate. If you double the water flow but don't adjust chlorine feed, the concentration drops, potentially allowing pathogens through. Proportional control ensures this balance is maintained dynamically. Key instrumentation concepts include flow measurement, signal scaling, like 420 milliamp to gallons minute, control signal generation, pump calibration and response, open loop versus closed loop logic, local loop versus DCS-integrated systems, This example comes from Lessons in Industrial Instrumentation by Tony Kuphaldt. It's open source and available for free at the link below. Whether you're new to controls or already working in the field, wastewater disinfection is a great way to understand how measurement and action go hand in hand. Like and subscribe to stay up to date with this series. We'll be covering more loops, systems, and logic as we go. Explore the full text. https://ibiblio.org/Kuphaldt Socratic model. Watch all episodes. www.youtube.com @Crash Course Instrumentation. Join the discussion. www.facebook.com/groups Crash Course Instrumentation.